lesson that we found most interesting was lesson 2, comparing magnetic and static electric interactions. Through this lesson, we learned how electric fields could be created, which was really interesting to us. I personally did not know much about static interaction or magnetic interactions. The part that I think I found the most interesting were the videos showing how different objects react with magnets and electrified tapes. I would not have thought that all objects would attach to the tape, such as a piece of wood. I also found sync to be interesting. Sync means that only steel, iron, nickel, and cobalt will react to a magnet. Some examples of this in the movie were the nickel strip, the iron nail, and the steel paper clip. I assumed beforehand that the copper wire would react to the magnet, however it did not. I also found it really interesting that whatever charges the object to have a static electric charge is on the outside of the object. We know this because when the pieces of the tape were wiped off, the static was gone. Another thing I was intrigued by was the magnets in the vacuum seal. One can assume that even with no air, the magnets will still interact, but seeing it done was very cool. This also applies to when the magnets were interacting with the large barrier in between. Okay, so now using the instructions from lesson 2, I'm gonna make my own electrical static field, sorry. So first I'm gonna grab one piece of tape and I'm gonna fold it over here and here. Then I'm gonna stick that onto my very messy desk, which we're gonna ignore, and I'm gonna mark that on the handle B for bottom. So now we're gonna take another piece of tape, try and get the same length, and fold in the little handles again, and then stick that right on top firmly. So now we got both pieces. We're gonna put a T on the top one. So now we're gonna slowly take it off the desk. Everything's stuck together. We have T and B, and now we are gonna quickly rip them apart and hope that this works. Okay, so now we should have 2 electrical fields. So first we're gonna try the top one. Pen. Let's try the other side. Okay, it's moving a little. Let's try a ring. Okay, you can see it. Oh! It attracted. Okay, let's try again with the bottom, which might be messed up because I put it the wrong side on my desk. Oh! See, it works. Thanks for watching!
Understanding how magnets and static electricity interact is really important because it helps us understand how things work in the world around us. From why some objects stick to magnets to how certain materials get charged when you rub them. These concepts are the building blocks to many cool technologies. A few examples are an MRI machine or even an electric motor. From watching demonstrations in class to doing hands-on experiments can spark our curiosity and maybe even lead to careers in science or technology or increase our knowledge for elementary education. Plus, knowing all these interactions help us solve problems in physical science or engineering. It is crucial to stay safe in industries like electric malfunction. So, diving into this topic isn't just interesting, it's essential for understanding how our world functions and for creating new inventions in the future. Something that really interests me is how in a speaker or like any type of like thing you listen to music in, you can find a permanent magnet and a coil of wire attached to each other on the flexible membrane, and an electric current passes through it. For example, like if you ever use a speaker, headphones, or even your phone or any other device, that is happening while you're using it.
I think that magnetic fields and static electric interactions are relevant in everyday life if that force, whether or not it can be wiped off, like of anything with a magnet, the magnetic force lies inside, and with the static electric interaction, it lies on the surface. For example, in everyday life, when getting gas, if you're shocked when getting the gas pump and going back into your car, you can wipe off your hands and then that shock will not be there. Same thing when doing laundry, when the clothes come out of the dryer and they're stuck to each other. By wiping the clothes off, they no longer are stuck to each other. But when using a magnet on a fridge, the magnet cannot be wiped off. It'll still stick to the fridge no matter what, if it's holding up a piece of paper or something. Even if you wipe the magnet, it'll still stick to the fridge. For example, this magnet, I can't wipe it off. No matter what, the magnetic field will stick to the fridge.